All right, towards the end of Algebra 2, we graph parabolas. Basic graphing of parabolas. We're going to do extensive graphing of parabolas in Chapter 8. We're going to still be doing basic graphing of parabola here in this class. When you see a simplified expression, y equals x squared minus 5, this y equals everything else, x is to the second power at the highest power, then that means that the graph itself is going to have the shape of a parabola. And parabolas can either turn upward, or downward, or right, or left. One of those four shapes happens. If one letter is squared and the other letter isn't squared. So if x is squared and y isn't, it's one of these two. If y is squared and x isn't, it's one of these two. All right? It's up to us to graph this, and we want to get the part where it turns. We want to get where it hits the bottom and goes back up. So we're looking for what x value is going to give me that bottom so I can go either side of it to get a couple more points to get this nice parabolic shape. And the way you do this is real simple. Whatever letter is being squared, that letter put as negative b over 2a. That's the same a and b that we used in the quadratic formula. A is the number in front of the x squared term, b is the number in front of the linear x term, and c is the constant, right? So this is the b, the number in front of x, this is a, the number in front of x squared. What is b in this problem? What? 1. No.
Is that a b or a 6?
That's a b. That a better b? Alright, did look kind of like 6. B, negative b over 2. What is b in this problem? B is the number in front of x to the first power.
Oh.
If it was y equals x squared plus x minus 5, then b would equal 1. What does it equal in this one? 0. There is no x term, right? So there's officially a 0x, which means b is equal to 0 in this problem. What does a equal? A is the number in front of x squared? 1. So 2 times 1. What's negative 0 over 2 times 1 equal? 0, right? So that's the magic number in this problem, 0. Have I lost anybody? It's the A, B, and C that we got with the quadratic formula. Suppose, and I just want to put this problem on hold for a second. Suppose the problem was y equals x squared minus 10x plus 9. If I did negative b over 2a, that's going to be positive 10, right? Over 2 times 1, that would be 5. 5 would be the magic number. 5 is where the bottom of this parabola would happen. 5 comma something would be the bottom of it. And then 4 and 3 and 6 and 7 would be numbers I'd want to pick. So in this case, I'm picking 0 because that's what I got out of negative b over 2a. I want to pick numbers less than 0 and numbers bigger than 0 to go with it.
So b is always the number that's in front of x?
B is always in front of x, a is always in front of x squared. And if there is no x term, b is equal to 0. If there is an x term, b is equal to whatever the coefficient of that x term is. Right? And again, the negative b over 2a just tells you where that bottom happens, or the top happens. The lowest point or the highest point, depending on which way the parabola goes. Next, once we've established the x coordinates of the chart, I've got to figure out y by squaring x and then subtracting 5. When you square x, you get positive, right? So this problem's easy enough. X squared minus 5. Square this number, subtract 5. 4 minus 5 is negative 1. 1 minus 5 is negative 4. 0 minus 5 is negative 5. 1 minus 5 is negative 4. And 4 minus 5 is negative 1. Again, my x's are here. I square them. Negative 2 squared is 4. Subtract 5 is negative 1. Negative 1 squared is 1. Subtract 5, I get negative 4, and so on. If, for some reason, I get some ridiculous equation that really is hard to evaluate, which can happen. In other words, the part where I put the y's in here in my head, let's say this says y equals 17x squared minus 5x plus 23. I don't want to square x, multiply by 17, multiply 5 times whatever I just said. So then I come to my calculator, just type it in. X squared minus 5. Go to my table, and I enter those numbers. Negative 2, negative 1, 0, 1, 2. And I get my y values out. So feel free to use your calculators if need be. For that, I hope you wouldn't use your calculator, but just know that you could. if it gets to be a little uglier than this, and you're graphing something uglier, if you can figure out the x's, you can figure out the y's. All right? So, once I've got my 5 points, -2, -1, -1, -4, 0, -5, 1, -4, 2, -1. Notice the 5 points create that nice parabolic shape that we were expecting. Then it's just a matter of connecting the dots. Try and hit the points, but if you miss one, you can always make it bigger or something like that. Or if you're more of a perfectionist, you could always erase the part that is offending you and redraw it. Okay? If the points you get don't give you a clear enough picture of what the graph was supposed to be, pick more x's. -1.5, -0.5, +0.5, +1.5. So -1.5, -2.75, -0.5, -4.75, 0.5, -4.75, 1.5, -2.75. All those points are still on the curve. Any x you put in, it'll give you a y that's on the curve. Once you plot all the points, connect the dots. They should make a shape. The shape should look like this if y is to the first, x is to the second. All right?